Good day, everyone. Today, I'll be presenting a very important concept in network security and cryptography fundamentals, intrusion detection. You might already know that we use firewalls, passwords, and encryption to prevent attacks in our system. But what happens if someone still manages to get inside the system? That's where intrusion detection comes in. Think of it like a security camera for our network. It doesn't stop people at the gate, but watches what they do once they're in. So, in this session, we'll go through what intrusion detection means, that is, the overview of intrusion detection, how it uses audit records as input, the main detection methods, which is statistical anomaly detection and rule based detection, challenges faced in intrusion detection, such as false alarms or base rate fallacy, advanced ideas like distributed detection systems, honeypots, exchange format, and finally, the summary of the overall intrusion detection. Is intrusion detection. An intrusion detection is any set of actions that attempt to compromise the integrity, confidentiality, or availability of a resource. Intrusion detection is the process of monitoring events in a computer system or network and analyzing them for signs of intrusions. It complements preventive security mechanisms like firewalls and encryption. So let's first define it clearly. An intrusion means any activity that tries to break into or misuse a system. It can be a hacker stealing data, an employee misusing access, or even a malware infection for the system. Intrusion detection systems act like a network watchdog. They continuously monitor logs, traffic, and behavior to identify any suspicious activity. Remember, prevention systems like firewalls only stop known threats. If something new slips through, IDS helps us detect it early so we can take action before major damage occurs. For example, think of an airport. The metal detector, which is a firewall here, stops people with metal objects from entering the airport. But if someone sneaks in something suspicious that isn't a metal, the CCTV cameras, that is the IDS here, notices this strange behavior and alerts the airport security. So, intrusion detection is about monitoring what's happening inside the system, not just blocking it from outside. Audit records. Audit data is used as input for intrusion detection. It is created for accounting, performance monitoring of the system, and for the system debugging. Can be used to detect unauthorized access or misuse. It includes login records, file access attempts, system calls, and network traffic data. So, every computer system keeps logs. It's like a diary of everything that happens. Audit records are these logs that record who did what, when, and how. Audit records are basically logs of everything happening inside the system. Who logged in, which files were accessed, or what commands were used to do so. For example, when you log in, it's recorded once. When you open a file, that's logged next. Even a failed login attempt or unusual file access are stored. IDS reads these audit records to spot patterns. If a user usually logs in once a day, but suddenly logs in 50 times in an hour, that's an unusual record. Imagine it like checking the CCTV footage after a theft. The audit records show what was active and who was active and what they did. By analyzing these records, the intrusion detection system can identify whether someone is behaving suspiciously in a given period of time or not. Statistical anomaly detection. It assumes the intruder behavior differs from the normal user behavior, builds profiles of normal activities, CPU usage, login frequency, etc. Any significant deviation is flagged as a possible intrusion. There are several approaches to statistical anomaly detection, and standard deviation, multivariate models, Markov processes, time series analysis, and clustering or outlier detection. So, statistical anomaly detection works by learning what the normal looks like. For instance, how many hours a user is usually active, how much CPU power they normally use, when and from where they log in. Thus, the system continuously monitors this activity and raises an alert if something strays too far away from this normal pattern. For example, if a user who logs in at 10 a.m. suddenly logs in at 3 a.m. and downloads gigabytes of data, that's a red flag. So that activity is flagged. This method uses mathematical models like averages and standard deviations to decide what counts as too different from the normal behavior. Let's take a real world example. The credit card company does this all the time. If you usually shop in Chennai and suddenly there's a transaction in London, they flag the transaction. That's anomaly detection in action. Rule-based intrusion detection uses rules to identify known intrusion patterns. Two main types. Rule-based anomaly detection compares observed behavior to known good behavior. Rule-based penetration identification looks for specific attack signatures. Example, detecting repeated failed login attempts or known spoiled exploit sequences. Effective for detecting known attack patterns. So, let's see what rule-based systems are. Rule-based systems uses the if-then logic, like setting up specific rules for suspicious situations. Example rules could be, if more than 5 failed logins happen in 1 minute, we'll raise an alert. If a user tries to access the restricted files, then block and log. So, in this rule-based intrusion detection system, there are two styles. One is the rule-based anomaly detection or anomaly-based rules, which focuses on detecting things that break the normal pattern. And the next style is penetration-based rules or rule-based penetration identification, which looks for exact signatures of known attacks, just like how antivirus tools work. In real life, let's say it's like a traffic police officer. They have rules. If someone jumps a red light or speeds above 80 km per hour, they are stopped. Similarly, the intrusion detection system checks for rules that defines what's illegal behavior. This method is fast and reliable for known threats, but can miss new or modified attacks that don't fit any rule. This can be a major disadvantage. Let's go into the problems faced by the intrusion detection system. The base rate fallacy. Even a system with high accuracy can produce many false alarms. Base rate fallacy that are actual intrusions that are rare, so false positives dominate. Key issue is distinguishing real attacks from normal but unusual behavior. High false alarm rates reduces the system's credibility and response efficiency. Let's look at this in detail. This is a statistical problem called the base rate fallacy. Imagine 1 in 10,000 events is malicious, but our system raises an alert for 1% of normal activity. We'll get hundreds of false alarms for every real intrusion. It's like a smoke detector that goes off every time we book. Soon people will start ignoring the signal. It means even if the detection system is 99% accurate, false alarms can still overwhelm you because real attacks are very rare. Let's take a simple example. Suppose out of 10,000 events, only 10 are the actual events that are being attacked. Your IDS flags, that is intrusion detection system flags, 1% of normal activity as suspicious. That's 100 false alarms versus 10 real alarms. So 90% of the alerts are wrong. So the people will not take this sensitively. The challenge is to balance the sensitivity, catching all the attacks, with specificity, not reacting or overreacting to normal behavior. Let's look at another type of intrusion detection system, which is distributed intrusion detection. Multiple IDS systems share information across networks. Coordination among these IDS systems improves detection of large-scale or distributed attacks. The central manager collects, correlates, and analyzes reports. It can detect attacks spanning multiple hosts or networks. So basically, today's attacks often hit several systems at once, like DDoS or distributed denial of service attack. As in large organizations, you don't have just one computer, you have hundreds or even thousands of systems. Each one might run its own intrusion detection system or IDS. Distributed intrusion detection means all these IDS units share information. A central system then correlates this data to detect coordinated attacks. For example, one computer sees repeated login failures. Another computer notices unusual traffic from the same IP address. Separately, they may seem harmless, but together they reveal a brute force attack in action. It's like a local police station sharing info with the national database. Suddenly, you can see a pattern of crimes that no single station could see it or notice it alone. This is the advantage of using distributed intrusion detection systems. Honeypots. A honeypot is a decoy system designed to attract attackers. This system appears vulnerable from the outside, but is closely monitored, provides information on attack techniques and behaviors, diverts attackers from the real systems. So, to detail this, a honeypot acts like a bait or a clever trap, a fake computer system set up to lure or attract hackers. It looks weak and tempting from the outside, but behind the scenes, every move the attacker makes is being recorded. Once they attack it, the administrators can study their methods safely. Why should we use honeypots? Because honeypots help researchers understand how attackers think, what are the tools they use, what vulnerabilities they might exploit. It's like setting up a decoy safe in a bank with fake money inside, while the cameras record the thief's method while stealing the money. Meanwhile, the real vault stays untouched. This way, honeypots not only provide intelligence but also distracts the attackers from the real targets. Intrusion Detection Exchange Format, the IDMEF. Standard format for sharing intrusion data between IDS, defined by IETF for interoperability, uses XML for representing alerts and events, facilitates correlation and analysis across different vendors. Different IDS tools from different vendors often use different data formats. This makes it hard to combine and analyze results together. To solve this problem, the intrusion detection message exchange format, that is the IDMEF, was created by IETF. IETF is the Internet Engineering Task Force. It's an open standards organization that develops and promotes voluntary interest standards like TCP and IP protocols. This format is defined by a standard XML format for alerts and event reports, so different systems can speak the same language. For example, it's like a police force across different states agreeing on the same crime report format. Now they can easily share and analyze data together. This makes large-scale intrusion analysis and coordination and correlation much easier. To sum up the overall intrusion detection, Intrusion detection is vital for spotting threats after preventive defenses. It combines statistical, rule-based, and distributed methods. Challenges may include managing false positives or base rate fallacy and large data volumes. Enhancements include honeypots, data sharing format IDMEF, and adaptive learning. So, in a world where threats evolve daily, intrusion detection systems act as a continuous eyes and ears inside the network, watching, learning, and warning us before the damage spreads. So, it's not just about building walls, that is, the firewalls, it's about having watchtowers, that is, these intrusion detection systems that keep looking out for danger even after the intruder is inside. Thank you.